All right, our second lesson for the week is multiplying and dividing rational expressions. So last time we talked about what a rational expression is and how to simplify them. Now we're going to talk about multiplying and dividing them. Remember, rational expressions are pretty much the same things as fractions. So let's think about our rules for multiplying fractions and dividing fractions. How do we multiply 1/2 times 1/3? How do we divide? What is 1/2 divided by 1/3? So remember, for multiple fractions, you multiply the tops together and you multiply the bottoms together. So this becomes 1 times 1 over 2 times 3, or it becomes 1 over 6. What about for dividing? Well, dividing, remember, we have the infamous half-brother of Kentucky Fried Chicken, KCF. We keep the first one, we change the sign, and we flip the second one. So instead of KFC, we have KCF. 1/2 times 3 over 1. Keep, change, flip. And now we do the same thing. We multiply the tops together and we multiply the bottoms together. So now we have 1 times 3, or 3 over 2 times 1, or 2. Perfect. Now before we get into this lesson, we're going to take a quick detour here to talk about something we've talked about a little bit previously, that being triple-decker, and this time we're going to be talking about everything up to quadruple-decker fractions. So how do we deal with a triple-decker fraction? How do we deal with something like 2/3 over 5? Well, the first thing I'd recommend, make sure that your middle line, or the second line down, is super big, because that'll help us understand what's happening. Remember, all fractions are division, right? So this is the same thing as saying 2 divided by 3. That's how your calculator does it. So what we're actually saying is this is 2 divided by 3, and what are we dividing that by? We're dividing that by 5, or 5 over 1. So now that this is dividing, and this is two fractions being divided, we remember our rule. It's keep, change, flip. So all we have to do is keep the first one the same, change that to a multiply, and flip the second one. So this becomes 2 times 1, or 2 over 3 times 5, so it's 15. So that's all we're going to do with triple-decker fractions. What about quadruple-deckers? So let's say we have 2/3. Remember, you're going to want to make that second line down really big to help remind us that this is division, over 5/4. And look at that. Now we have a fraction divided by another fraction. So remember, this is why this line in the middle is so big. We need to remind ourselves that we are dividing. So this is 2/3 divided by 5/4. Now that this is this, we know to keep, to change, and to flip. So this will be equal to 8 over 15. The real trick here is remembering how to get from triple or quadruple decker fractions to making it a fraction divided by another fraction. Remember, this is the same thing as a quadruple decker, if that helps you, or this is just a fraction divided by a number. This is just a fraction divided by a fraction. And then we know how to divide fractions. All right, now let's get into multiplying or dividing rational expressions. We're going to start simple and then work our way into the more confusing. So let's start with a simple one. How would we multiply together 6 over a squared times -2 over a cubed? Well, look, these are just fractions, right? We could replace this with a 1, we could replace this with a 2, so this is the same thing as 1/2, right? We're just looking at fractions. And how did we say we multiplied fractions at the beginning of this lesson? We multiply the tops together, so this is 6 times -2, and we multiply the bottoms together. So this is a squared times a cubed. And now we just simplify. 6 times negative 2 is negative 12. And a squared times a cubed, remember when these are multiplied together, we add the exponents. So this becomes a to the 2 plus 3, or a to the 5th. All right, so that one's pretty simple. Let's look at one that's a little more difficult. Let's say we have x plus 5 over 3x minus 3 times x minus 1 over x squared plus 10x plus 7. Now this looks like it's going to be a nightmare. We're going to have to FOIL on the top, then we're going to have to do a triple FOIL on the bottom. That sounds like a pain. Thankfully, mathematicians are lazy and efficient, so they found another way to do this. What you're going to want to do when you're looking at this is we're going to factor. So the first thing you're going to want to do is factor all these terms. X plus 5 stays the same. We can factor a 3 out of the bottom of that, and we're left with x minus 1 times x minus 1 stays the same, but we have to factor x squared plus 10x plus 7. We'll do this one with an ACB chart, but remember I'll be skipping those for most of these. Looking for factors of 7 AC that add up to 10. Oh wait, I flipped those. Let's change this. We're going to make this is going to be x squared plus 7x plus 10. There we go. So we're looking for factors of 10 that add up to 7. So what are our factors of 10? It's 5 and 2, and that adds up to 7. So this becomes x plus 5 times x plus 2. And now, because mathematicians are lazy, we're just going to multiply these and leave everything in parentheses. X minus 1, x plus 5, and x plus 2. And look at that. We have some things that are the same on the top and the bottom. We have an x plus 5 in the top and bottom, so those will cancel. We have an x plus 1 in the top and bottom, so those will cancel. Meaning that we can simplify this down. And this is the reason that we leave them in the factored form. It allows us to cancel them out. We have nothing left on top, so nothing is going to turn into 1. And we're left with 3x plus 2. All right, now let's get a little bit more difficult. Let's look at division. So now let's look at x squared minus 25 over 4x plus 28 divided by x minus 5 over x squared plus 9x plus 14. Right, perfect. Now, we are dividing fractions here. So what do we do when we divide fractions? Well, we keep the first one the same. We change the sign, and then we flip this. So our bottom goes up to our top, and our top becomes our bottom. So this becomes x squared plus 9x plus 14 over x minus 5. And now, to make our life simple, we're going to factor these. So x squared minus 25 will become x plus 5 times x minus 5. What do we get on the bottom? Pull out a 4, we're left with x plus 7. And we're multiplying this by, what's x squared plus 9x plus 14? So 14 into 9 is going to be 7 and 2. So this becomes x plus 7, x plus 2 over x minus 5. And here's a cool thing. You don't even have to multiply these all together into one sandwich. Now we can look for things that are the same on the top and bottom. Look, we have an x minus 5 here and an x minus 5 there. Those are going to cancel. We have an x plus 7 there and an x plus 7 there. So those are going to be canceled. What are we left with? We have an x plus 5 and we have an x plus 2 on the top. And we're left with a 4 on the bottom. And this is a perfectly reasonable way to leave your answer. Don't have to FOIL those out again. Just fine to do this. All right, so that's all we have. When you're multiplying or dividing, just think about these like fractions. Multiply or divide them like fractions, then you're going to factor to make your life simple and to cancel these out. Let's give you all your practice problems. We're going to start with simplifying a triple-decker. Then you're going to simplify a quadruple-decker. Then we're going to do some multiplication and division here. All right, and then for your division, we'll put that all the way down here. So you have 4k plus 8 over 2k minus 10 divided by k squared plus 6k plus 8 over 6k minus 30. So go ahead and pause the video, do these practice problems, and then meet back up with me. Make sure you did these properly. All right, let's get started with a triple-decker. Remember, we said triple-deckers are the same as a fraction divided by something. So this becomes x over y divided by z, and we know that z is over 1. So that's the same thing as x over y times 1 over z, meaning our answer for this is x over y z. Right, what about for a quadruple? Well, that's a fraction divided by the bottom fraction, or that's a fraction multiplied by the flipped fraction. Right, and we have a 2 and a 4. Those cancel out, so this becomes 2/3. All right, for problem 3, we're multiplying, meaning we just multiply the tops and multiply the bottoms. But let's factor first. 3x squared, not much we can do there, but we have x plus 2, not much we can do there. Right, x squared plus 3x plus 2. That we can factor into x plus 1 times x plus 2 divided by x. And would you look at that? We have an x plus 2 in the bottom and an x plus 2 in the top. But notice we also have an x squared, or an x times x on the top, and we have one in the bottom. So we have an x and an x. Those will cancel out, meaning that what we are left with is 3x times x plus 1. All right, and for our division problem, dividing fractions is the same as keep, change, flip. So we're going to keep. We're going to change this into multiplication, and we're going to flip. Now we're going to factor and break these down. We can pull a 4 out of those, so this becomes 4 times k plus 2. We can pull a 2 out of the bottom, so this becomes k minus 5, times, let's pull 6 out from those, we're left with k minus 5. And when we factor this bottom one, we're left with k plus 2 times k plus 4. Right, what do we have the same on the top and the bottom? We have a k plus 2 and we have a k plus 2. We have a k minus 5 and we have a k minus 5. So we simplify that down. We're left with 4 times 6 over 2 times k plus 4. Right. Now we also have a 2 in the top, and we have a couple of 2's we can cancel out within the bottom. Or in that 2 in the bottom, we have a couple of 2's we can cancel out in the top. So remember, this is 2 times 2 times 2 times 3. Let's cancel out that 2 on the bottom with one of those. And what are we left with? We're left with 4 times 3, so 12 over k plus 4. All right, that's all we have for this lesson, so go ahead and do the homework.